student, those are appearing for Wbchse exam semester 4, Neet joint or any type of Cbse or Icse board are quite bit important for the chapter coordination chemistry. I just assist you for the overall description and overall gives the idea for this chapter, so that you can solve any type of competitive exams question and any type of board exam easily. And also this chapter you may get a overall idea and total the chapter be cleared, and any type of doubt you clear from this lecture. So at first, the coordination compound is very important, and it is very crucial chapter for your competitive exam. Coordination compounds, at first we describe about the coordination compound, what are their uses in daily life. एक्चुअली हम सब देखे हैं कि हमारा जो ब्लड है उसका जो मेन जो प्रोटीन है हीमोग्लोबिन, और जो प्लांट सिस्टम है उसका क्लोरोफिल एंड विटामिन B12, मेनली द सेंट्रल एटम इज कोबाल्ट. तो different type of central atom when combined with different type of central atom combined with ring, or here the hemoglobin structure. In hemoglobin the central atom is iron. Between iron, all the porphyrin rings are attached here. These are coordinate complexes. These ring type structure are called coordinate complexes. And there are so many uses in coordinate complexes in our daily life, such as at first we say that the hemoglobin, chlorophyll, and vitamin B12, these are simply uses coordination compounds, and to remove the hardness of water and the extraction of different type of metal from its ore. Generally we know that outside in our human body the blood coagulate, but they give special type of compound that is called EDTA, ethylene diamine tetraacetic acid. Adding that the blood cannot be coagulated outside our body. So there are different type of uses present in our coordination complexes. Here we at first explain different type of salts present. The salts are of three types. One is simple salt. Simple salt means these salts forms cation and anion in aqueous solution. That is, example is NaCl, here Na plus and Cl minus form. Na plus and Cl minus in aqueous solution. These type of salts are called simple salts. Another is double salt. Double salt means, here let us take an example, K2SO4 Al2SO4 whole 3 24H2, that is called alum, potash alum. Here the cation and anions are K plus SO4 minus 2 Al plus 3. In aqueous solution the cations and anions are in freely movable, and if we get any type of experiment for sulfate ion, aluminium or potassium ion, they get positive result. But in case of complex salt, here example is K4FeCN whole 6. If it is in aqueous solution, the Fe plus 2 or Cn minus ion, we don't have any experiment for Fe plus 2 and Cl minus ion in that solution, because in the solution the complex that is present in third bracket cannot be dissociated into its conjugate ion, that is Fe plus 2 and Cl minus. So it is one type of complex that cannot be dissociated into its cation and anionic form. Here, at first, Alfred Werner, scientist who discovered COCl3 in ammoniacal solution and get different type of compounds, he found their color are also be different and their ionic mobility also be different. So let us take Werner experiment. Werner saw that COCl3 when it reacts with ammonia, he found different type of complexes: COCl3.6NH3, COCl3.5NH3, COCl3.4NH3, COCl3.3NH3. This type of compounds, this type of complexes have different color and their ionic mobility also be different. Their ionic mobility means number of ion present. Number of ion here COCl3.6NH3, number of ion is 4. That is total number of cation plus anion, that is equal to 4. Let us explain how the cation total number of ion be 4. If COCl3 6NH3, we draw the actual structure of COCl3 6NH3, CO NH3 whole 6 Cl3. Here in COCl3 6NH3, the third bracket present in the between the third bracket, that is called the coordination zone. Coordination zone. And outside the third bracket, it is called ionization sphere. That is, ion forms here, there is no ion form. The coordination zone, the CO is the central metal ion. Central metal, around the central metal ion, there are 6 ammonia molecules bonded directly. That is called ligand, which are bonded directly and satisfied the one type of valency. Here Werner explains two type of valency. One is primary valency and the another is secondary valency. Primary valency, which satisfied the oxidation number of central metal ion by the anionic species, that is called primary valency. Here oxidation state of the central metal ion of CO, cobalt, is +3. +3 central metal ion oxidation state satisfied by 3 Cl minus outside the third bracket, that is called ionization sphere, or it is counter ion. So counter ion. So the primary valency here is 3 and cobalt surrounded by 6 ammonia molecules, 6 ammonia molecule which directly attach to the central metal ion. Here central metal ion के साथ जो 6 ammonia molecule bonded है directly, तो इस 6 ammonia molecule को हम बताएंगे वो है secondary valency or coordination number. Here the coordination number of central metal ion is 6, as 6 ammonia molecule bonded directly to the central metal ion. So here if we add AgNO3 in the complex solution, there are 3 mole or 3 molecule of AgCl precipitated. AgCl, number of AgCl precipitated with 3, as the 3 Cl minus ion present as counter ion and it is outside the third bracket. So AgNO3 added to this solution, the number of 3 molecule of AgCl precipitated. If we study the structure of COCl3 5NH3, here the actual structure is CO NH3 whole 5 Cl outside third bracket Cl2. If we add AgNO3 to this solution, 2 AgCl precipitated, 2 molecule of AgCl be precipitated here. As we know firstly that the coordination number of CO is 6, that is the secondary valency. If we study this complex COCl3.5NH3, here it is to be seen that CONH3 whole 5 Cl and in the outermost third bracket 2 Cl minus present. These 2 Cl minus reacts with AgN3 forms 2 molecule of AgCl. Here also it is to be noted that here also the number of total ligand is 5 NH3 and 1 Cl, that is 6. So the secondary valency of CO, that is carbon CO, secondary valency is 6 and it is the coordination number. So coordination number of central metal ion is 6 and primary valency of CO is here. Primary valency of CO is CO oxidation number is 3. That is overall 3 number of Cl minus ion present. So the primary valency here, primary valency is 3 and secondary valency is 6. It is at first we say that ionic mobility here number of total ion is 4, 3 Cl minus and 1 is positively charged cationic species. So total number of ion be 4. But here total number of ion is 2 Cl minus and 1 cationic species. So total number of ion be 3. So ionic mobility changes, that is decreases from top to bottom as the number of ion be less, as the number of ion be decreases from top to bottom. Here number of total ion be 4, here number of total ion be 3, here 2 and there is no number of ion present. And AgCl, if we get number of AgCl precipitated, here 3 AgCl, here 2 AgCl, here 1 AgCl, here no AgCl precipitated. And if we know the COCl3,4NH3, if we draw the structure of COCl3,4NH3 according to Werner, firstly when get different type of coordination compounds, their color be different, their ionic mobility be different. So he concluded that all the coordination compounds don't have same structure, that is depends upon the valency. It is varies as the valency of the central metal ion varies. The central metal ion and the structure of the coordination complexes are quite bit different, little bit different. So experimentally he found that number of AgCl, number of ionic mobility, number of ion form, that is also bit different. But if we take COCl3.4 NH3 CO NH3 whole 4 Cl2 dot Cl, outside the third bracket, that is the counter ion is only 1 Cl. So if we add AgN3, number of AgCl precipitated is 1 AgCl, 1 mole AgCl precipitated. This AgCl minus reacts with Ag plus and AgCl precipitated only 1. And here also the secondary valency or the coordination number of central metal ion is 6, as 4 ammonia molecule and 2 Cl molecule, overall 6 number of particle attached directly to central metal. So the structure of this element is CO NH3 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 Cl Cl. Maybe that it is cis isomer. We discuss this type of isomers later. So here directly bonded and non-directly bonded number of particles, non-directly bonded is 1 Cl. Here also the primary valency is equal to 3. Primary valency, that is called the number of negatively charged particle or attached to the central metal, which is not directly attached, maybe directly attached or not directly attached to the central metal, but the which satisfies the valency of the central metal ion, that is called the primary valency. Here if we know that if we draw this structure, there is no Cl minus outside the third bracket, and as a result AgCl cannot be precipitated. It is the Werner's experiment. After the Werner's experiment, we discuss about the isomer of the compounds. Isomer means isomer. Here, isomer means number of molecular formula is same, but their characteristic is different. Such as two types of isomer present. One is structural isomer, and another is a stereoisomer. A structural isomer and another is stereoisomer. Structural isomers is divided into four parts. One is ionization isomer, one is coordinate isomer, one is linkage isomer, and another is hybrid isomer. At first, we discuss about this type of structural isomer, then we go to stereotype isomer. The stereotype isomers are of two types. One is geometrical isomer and another is optical isomer. Geometrical isomer are of two types, cis and trans. Let us take one by one, give an example of ionization isomer, coordinate isomer, etc. Ionization isomer means, let us take an example, ionization isomer CO NH3 whole 5 SO4 Br and CO NH3 whole 5 Br SO4. These two type of isomers are called ionization isomer, as the number of anion exchanges between the which is in previous which is present in third bracket, now it is outside the third bracket, and outside the third bracket it is inside the third bracket. So here simple example of ionization isomer can be detected or identified by if we add AgNO3 solution to both these. One is at first the B, where the Br is outside the third bracket, it forms AgBr. Precipitation of AgBr forms in the first one, but there is no precipitation of AgBr as the Br is present here inside the third bracket and cannot be dissociated easily. So AgBr precipitation cannot be formed in this case, but AgBr precipitation formed in the case where outside the third bracket Br minus is present. That is called the ionization isomer. Here coordinate isomer is give an example of coordinate isomer. Coordinate isomers are coordinate CO NH3 whole 6 Cr Cl whole 6 and Cr NH3 whole 6 COCl whole 6. Here the central metal ion changes, CnH3 whole 6, CrCl whole 6. Now CrNH3 whole 6 and the cations are exchanges. These type of isomers are called coordinate isomer. In this question, there are different type of question comes where such type of 2 or 3 isomers are mentioned, and you have to explain what type of isomers they are, coordinate or hydrate or linkage isomer, etc. Now let us take an example of linkage isomer. Now let us take an example of linkage isomer. Here NH3 whole 5 ONO and Here NH3 NO2. Here the linkage are different. The Cl chromium is the central metal and 5 NH3 bonded directly, and one NO2 group. Here NO2 and here is ONO. That is nitro and nitrito. The nitro group, there is central metal ion directly attached to N and directly attached with N. But here the central metal ion attached with O. The linkage are different. That is the combination to the central metal ion is different. So it is called linkage isomer. And one is hydride isomer, Cr H2O whole 6 Cl3 and Cr H2O whole 5 Cl2 dot H2. These are example of a hydride isomer. Hydride means number of water molecule which is inside and in another one that is outside. These type of isomers are called hydride isomer. There are so many type of isomers present in there are generally structural isomers are 4 type: linkage isomer, coordinate isomer, hydride isomer and ionization isomer. Now we see that the type of stereoisomer. There are 2 types of stereoisomer: geometrical isomer, that is divided into cis, trans, fish and mud, and optical isomer. So let us start the stereoisomer. The stereoisomer are of 2 types: geometrical isomer and optical isomer. Geometrical isomer are of generally 2 types, but it divided into 4 types. One is cis, another is trans, fish and mud. Let us start with example given by one example. Geometrical isomer, cis, trans isomer. Actually, for coordination number, the element which has coordination number 4. Example of coordination number 4. There are cis isomer present and trans isomer also present, such as PT NH3 into Cl. It is 2 different types here. One is cis and another is trans. Cis is PT Cl Cl NH3 NH3 and trans is PT Cl Cl NH3 NH3. Cis form is known as cisplatin. Cisplatin generally used as anti-cancer drug. Here cis